All right, so today we're going to look at midpoints and distance on a plane. So we start with a formula for finding midpoint in the coordinate plane. So if you have a segment which has endpoints, A at x1, y1, and B at x2, y2, the coordinates of the midpoint of segment AB are given by the formula. The midpoint is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. We're just averaging the endpoints together, first for the x's, then for the y's. So we're really doing, it's just two different things. And we've already done this before, okay? We just did it on a number line instead of on the coordinate plane. So find the coordinates of the midpoint of segment RS for R at -7, 9 and S at -16, -3. So the midpoint is going to be equal to half of -7 plus -16 over 2, comma, half of 9 plus -3 over 2. Oh, what am I doing?
Yeah, I know.
I did half twice. My fault.
Yeah.
There's no half. It's just over 2. Over 2 is half. I tried to do it twice. Rather stupidly, I might add, but so that's going to be -23 over 2 and +6 over 2. So the midpoint's going to be -11.5, +3. So this is the most straightforward problem. They give you both of the endpoints. Grace, you're looking at it funny. What's up?
Never mind, I got it.
Okay. Yeah, if at any point you're like, wait a minute, I need a second to process, just let me know. It's not a big deal.
Wait,
Okay.
how'd you get it? Oh. You literally just combine the top numbers and then divide?
Yeah.
Okay, that makes sense.
Okay.
Yeah.
All right. So this second one, it says T is the midpoint of segment KJ. If the coordinates of K are 7, -9, and the coordinates of T are -14, -4, find the coordinates of J. Okay. So substituting into our formula, the midpoint is T. So I've got -14, -4 is equal to, one of the endpoints has an x coordinate of 7, and I don't know the other one. I'm going to just call it x over 2. And then for the y coordinates, I'm going to have -9, and I've already used x, and this is a y coordinate. Why would I call it x? Let's call it y. Then to solve that, I'm going to split it into two separate equations. -14 is equal to 7 plus x over 2. And for the y's, -4 is -9 plus y over 2. Now, could you do the division? Yeah, you could. I wouldn't, for two reasons. Number one, yeah, here you're going to get like 3.5, and I'm like, I'd rather not get a fraction. The second thing is you got to get rid of the 2 sometime or another, right?
Multiply?
By?
Multiply? Question mark?
I'm
Oh.
sorry?
2 on both sides?
Yep. Multiply both sides of the equation times 2. So that's going to give me negative 28 is equal to, here, 2 divided by 2 is 1, and 1 times 7 plus x is just 7 plus x. Subtracting the 7, we have negative 35 as the x-coordinate. Same thing here. Multiply both sides of the equation times 2. On the left side, we have negative 8. On the right side, the 2's divide out to be 1 times negative 9 plus y is negative 9 plus y. Add 9 to both sides and we get y as 1. So the coordinates of j are negative 35, positive 1. Fake bell.
So why do you put, like, why do you put 7 plus x over 2 and negative 9 plus y over 2 and not negative 14 minus, or negative 4 over 2?
What? I was with you at first. Why don't you put negative 14 plus x over 2?
Yeah.
Because which one is the midpoint?
T.
T. So the midpoint always goes by itself.
Okay.
And then we're averaging the endpoints. We know one endpoint, but we don't know the other endpoint.
Okay.
Okay? All right. So to find the distance between 2 points on a number line, we subtracted the coordinates. Remember, we did that earlier. We can also use this same idea with the Pythagorean theorem to find the distance between 2 points on a plane. And I have a separate sheet for you to help lead you through that idea.
Is this the homework?
No, this is the supplemental notes. So let me start by reminding you of the Pythagorean theorem. The Pythagorean theorem says that a squared plus b squared is equal to c squared if you have a right triangle and the lengths of the legs are a and b and the hypotenuse is c. All of that has to be true. If it's not a right triangle, this doesn't work. Okay, when you get to pre-cal, you'll learn a different formula that works when it's not a right triangle. It's a pretty cool thing called the law of cosines. But that's a couple of years down the road. Don't worry about it yet. So, let's whip through these pretty quickly. Find the length of the hypotenuse of each right triangle. If the answer is not a whole number, let's leave it as a square root. So, this will be 6 squared plus 8 squared is equal to d squared. You're like, why didn't you call it c? You'll see in just a minute. That's 36 plus 64 is d squared. That's 100 is d squared. Take the square root of both sides and we have 10 is the distance. Because the square root of 100 is 10.
Right.
Same idea on this one. It's not going to come out to be quite as nice. We'll have 10 squared plus 5 squared is d squared. It's 100 plus 25 is d squared. So 125 is d squared. And since 125's square root is not a whole number, for right now we're just going to leave it as that. I know you guys did simplifying of square roots in algebra, but we'll get to that later. We're not going to use it enough right now for it to be worthwhile.
That's also the fake alpha.
Yeah, I'm just trying to remember when this class is actually over. 57. All right. So, on a graph, we could call the horizontal distance between 2 points delta x. Have you guys used the delta in science before for the difference between two things?
I think we did last year.
Okay, so when you see, it looks like a triangle, but it's got this one side is darker. That's the Greek letter delta. The reason they used delta is to remind you that it is the difference. It's the difference in x. And then the vertical distance we could call delta y. For each of the following, we want to find delta x and delta y, and then the distance between the 2 points, d. That's why I called this d, because it's the distance between the 2 points. Okay? All right, so delta x. Well, we can just count that, right? 1, 2, 3, 4. Delta x is 4. And then for delta y, it's 1, 2, 3. And then we can do the Pythagorean theorem. 4 squared plus 3 squared gives me the distance squared. So 16 plus 9 is d squared. 25 is d squared. Take the square root. The square root of 25 we know is 5. So this distance is 5. In the interest of time, we're not going to do the second one. I want to move on. Now, remember that in order to find the distance between 2 points on a number line, we just subtracted the 2 coordinates, right? So, like for this, if we're trying to find the length of AB here, it's just 12 minus negative 7, which is 19. And if we're trying to find the length of CD, it helps if you start with the one that is further to the right. That's going to be negative 5 minus negative 23, and that's 18. Now, before we move on to the next page, look at this. We counted how far this is, but look at the x-coordinates. It was 5 and 1, right? What could we have done to get 4? We could have just subtract. And for the 5 and 2, we could have subtracted that to find the 3. So, let's do that here. Let's find delta x and delta y for these ordered pairs. So remember that the x and the y-axis are just number lines. It's just that one is horizontal and the other one's vertical. So delta x is going to be negative 4 minus negative 6, which is positive 2. And then delta y would be 7 minus negative 3 is 10. And again, in the interest of time, I'm not going to do the next one. I want to make sure we get to everything. So once we have delta x and delta y, couldn't we do the Pythagorean theorem to find the distance between the 2 points? We don't even have to have the drawing to find this distance. So if we're doing this without graphing, we could find delta x which would be 6 minus negative 4. So the change in x is 10. Delta y would be 8 minus 3 is 5. And then we could find the distance between the 2 points. We would take 10 squared plus 5 squared is equal to d squared. We've done these numbers just a moment ago. We get d is the square root of 125. So delta x was 10, delta y was 5, and the length of RS is the square root of 125. And we can do that for any of these. We don't actually have to graph at all. So what if we wanted to do this all together as one formula instead of find delta x, find delta y, do the Pythagorean theorem? So to find delta x, we're subtracting. To find delta y, we're subtracting. And then we're squaring them, then we're adding them together, and in the end we take the square root. Right? Let's go back to this. So what we could do is think about this little triangle where this is delta x and this is delta y. The change in x and the change in y are the difference in x and the difference in y, and we could do the Pythagorean theorem. But we can actually do this all in one step. This distance is going to be equal to, we would find delta x, that would be x2 minus x1. Find delta y, y2 minus y1. To do the Pythagorean theorem on those, we squared each of them and added them together. And then in the end, we took the square root. That is the distance formula. It comes from the Pythagorean theorem. It's just all of the parts that you would need in the Pythagorean theorem all at once. So let's look at a couple of example problems. Find RS. Remember when it says RS with nothing above it, that means the length of segment RS. You're finding the distance between R and S. For these 2 points, leave your answers as square root and then estimate its value. All right, so the distance from R to S will be equal to square root of, it doesn't really matter which one you make x1 and which one you make x2. You're just going to subtract. So I'm going to do negative 12 minus negative 3. If you did it in the opposite order, it's still going to work out. Plus negative 2 minus 7 squared. So now I have substituted into the distance formula. So this will be the square root of negative 12 minus negative 3 is a negative 9 squared plus, this is also negative 9. How convenient. It won't always come out that way. So this will be the square root of 81 plus 81. It's the square root of 162. It says, go ahead.
Why'd you put the -2 and -7 in the same parentheses?
Because those are both y coordinates. Remember, I'm finding delta y here. So I want to subtract the 2 y's.
Oh, I just didn't see that.
Okay? Now, to estimate this, you have to know a little bit about perfect squares. 13 squared is 169. So this is a little bit less than that, right? A little bit less than 169. So this is a little less than 13. Because if it was the square root of 169, it would be exactly 13. All right, last thing. If they give you a diagram, you can put the coordinates on it and use the distance formula if you want to, or you can just do the Pythagorean theorem. It's entirely up to you. This is 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. I typically just count it and do the Pythagorean theorem. To me, that's a little faster. It would be 9 squared plus 6 squared gives me AB squared. So it'd be 81 plus 36 is AB squared. That's what, 117?
Yes.
So AB is going to be equal to the square root of 117. And here it wants me to estimate it, but it wants a different way. It says, find what two whole numbers this is in between. So you have to think of what squared is just a little bit less than 117 and what squared is just a little bit more than 117. All right, 10 squared is 100. And 11 squared is 121. So this is between 10 and 11. Which one is it closer to?
11.
It's closer to 11. So it's just a little under 11. Okay, any questions? Sorry about zooming through some of that. I used to do this during the block period. Yeah, we didn't have a block period, so we didn't have the time for that. All right, your assignment is in the book tonight. I hope you have a great day and you can stay dry. And I'll see you tomorrow.